Okay, guys, hopefully you enjoyed that demo. So now let's keep talking about stretch clusters. So we saw how to configure, in my case, a 5-node stretch cluster. Remember, 2 hosts on one side, 2 hosts on the other side, and a 5th host, which is my witness appliance. Here, just like I showed you in my demo, they mention that it's very easy to replace your failed witness if necessary. Now, that was not available back in the old days, back in 6.1, but that has been available for a few versions now. If you have vSAN 6.7 or 7.0 or 7.0 Update 1, guess what? That feature is there. So remember, all you would have to do is simply deploy a new one, add it to your inventory, add the second VM kernel port, then click on Change Witness Host. Wait about 3-5 minutes, and then make sure that you rebuild those witness components. So make sure you go to Skyline Health, and then you simply specify that you want to repair the objects immediately. Now, when you take a look, what we try to show you here is that when you put the witness appliance in maintenance mode, there's nothing to evacuate. So when you compare what you see, when you try to put a host in maintenance mode versus this witness appliance, the big difference is that with a regular host, you have the 3 typical choices: full data migration, ensure accessibility, and no data migration. That is not the case when it comes to the witness. Remember, you can live without those witness components. As long as you have the majority of the votes, you're still doing okay. And if you take a look, if needed, one of the things you could do is you could always go to Skyline Health and take a look at what's going on with your stretch cluster. Like I said a minute ago, if you replace your witness appliance, what you'll have to do is go to Skyline Health. For obvious reasons, you're not going to see all the tests in green. And then at that point, you'll have to repair the objects immediately. Now, when you take a look, you can see that there's a whole section of tests for stretch clustering. You can see, for example, the system could complain that it couldn't find the witness. Notice again, for example, you may have more than your 3 full domains. Remember, you have site A, site B. The witness is the 3rd full domain. So if you're building a stretch cluster and you accidentally forget to add one of your hosts to one of those full domains, then you'll end up with 4 full domains. The system will complain and it will tell you, hey, you got too many full domains. Now, when you take a look, you also see additional errors that the system may realize that you're going through. So, for example, notice you may have unicast-related problems. Notice again, maybe you don't have any disks claimed on the witness host, and so on. Now, I built a 5-node cluster. That's not what you're going to do when you get to the lab. You're going to build a bigger one. Now, there's a reason. When we first introduced stretch clusters, all your VMs had to be 2-way mirrors. One submirror in one location, one submirror in the other. Now imagine if you have a regular stretch cluster like the one I built, and then you lose the disk that contains the local copy of the data. Temporarily, that VM will use the remote copy. And you're going to have to wait until you finish rebuilding that missing submirror. Performance is not going to be the same if you're relying on the remote copy. Now, not in 6.1, but much later, we introduced variations to stretch clustering. For example, now you have new policies, such as the one that allows me to have a VM that is a 2-way mirror, where we're talking about one copy of the data on one side, one copy on the other. But then in turn, each of these copies is going to be redundant. So that would be like the equivalent of a 4-way mirror. Now we're talking about 2 submirrors in one data site, 2 submirrors on the other, and 3 witnesses altogether. One witness for the 2 submirrors in site A, another witness for the 2 submirrors in site B, and then the 3rd witness, which is the witness between data sites. So how do I build that type of VM? Notice you have to combine different rules to create a brand new policy. what you would have to do is you would choose under site disaster tolerance, the option dual site mirroring. And then when it comes to failures to tolerate, you will use one failure rate 1. Now that would require 7 servers altogether. 7. I'm talking about, 7. 3 in one data site, because you need sub-mirror, witness. 3 on the other, sub-mirror, and witness. And a 7th, which is going to be your witness host. That's what you're going to be doing in the lab. There's another choice. The next choice entails that you have a VM that is a two-way mirror, but in turn, each sub-mirror is really RAID 5. Now that requires 9 hosts, because remember, RAID 5 requires 4. So we're talking about 4 plus 1. How do I build that policy? Once again, I combine dual site mirroring, parentheses stretch cluster, with RAID 5. When you take a look, this, again, is the one that requires 7 servers. As you can see here, you have 2 replica components in each site. You need a witness for basically each set of mirrors. And then again, you have that third witness. And again, the third witness is going to be always on your witness site. Now you can imagine in this case, if I lose one of the copies of my data in my local site, I still have another one there. And I get to rebuild that missing copy using the local copy, not necessarily the remote one. And if you take a look, this one talks about combining that with RAID 5. So this illustration doesn't look right. Again, in this case, you would need 4 hosts in each location. Now, when you take a look, here they mention that again, in a perfect world, the 3 sites are communicating with each other. Notice here's what they mention. The master node, the backup node. Again, these 2 entities are communicating with each other, and they're also communicating with the witness. They're pinging each other all the time. Now, how can I tell? Not that it matters, but how can I tell who the master or the backup is? Basically, you go to the command line and you could type ESXCLI vSAN. And when you type ESXCLI vSAN, you will have different namespaces. So if you type ESXCLI vSAN cluster get, that will show you whether you are the master, the backup, or obviously an agent. Remember, always one master, always one backup. Everybody else is going to be an agent. If the backup fails, one of the agents gets promoted. If the master fails, the backup then becomes a master. And if you take a look, what we have next is a series of questions. So take a look at this. Let's assume that we have two-way mirror VMs, just plain vanilla two-way mirror VMs. If I have a virtual machine, let's say running on datasite 1, and I have another machine running on datasite 2, what happens if you lose datasite 2? In this case, you have 2 VMs running on datasite 2. Those are VMs 03 and 04. Those would crash. They would restart, obviously on datasite 1. Who restarts them? HA. And when you take a look, that's the answer to the question that you just saw. Now let's take a look at this one. In this case, you're talking about having a VM. Once again, we're going to stick to two-way mirror VMs. In this case, I'll lose one host. So let's stick to one VM. Let's say we have VM1. If VM1 is running on host 1, and let's say host 2 crashes, that VM will continue to run. Now, there is no concept of data locality when it comes to VMs. That means what? The VM could be using CPU and memory on host 1, but maybe his sub-mirror was on host 2. In any event, if the VM is running on host 2, it crashes. It will restart, and your DRS rules will tell it to restart and datasite 1. Now, on the other hand, if it was running on, let's say, host 1, yes, maybe it was affected temporarily because host 2 went down, because maybe that's where you had the replica component. But if you didn't have the replica component at all in host 2, then obviously you couldn't care less. He'll still be okay. And again, you can play with this. And you're going to have a lab where you test these type of scenarios. I'll do another demo and I'll show you that. Here again, you have the answers. So once again, if the VM was running on that host, the one that crashed, HA will restart it. Now let's take a look at this one. In this case, this is what I showed you before. You lose the witness. Once again, we know the answer to that. The VMs will continue to run. If you cannot bring back the witness, all you have to do is deploy a new one and replace it. But again, remember, in this case, the VMs would have, for obvious reasons, the majority of the votes present. And here again is your answer. All right, so let's talk about this one. In this case, your preferred data site cannot see the witness, but he can still see the secondary site. So the VMs, once again, are unaffected because you still have the majority of the votes. Now, you better fix that network problem, correct? But in any event, here, just remember the VMs will continue to run. And here you have the answers. So let's take a look at this one. We've already talked about this. I don't want to spend too much time with this. If my data site 1 cannot talk to data site 2, but both can see my witness site. Remember, all the VMs in your non-preferred site will power off and they will restart in your preferred site. We talked about that at the beginning of the lecture. And here you have the answers. Now, let's take a look at this one. In this case, right, it says, in this scenario, the preferred site has failed and the vCenter happened to be one of the VMs there. What happens in that case? Simple. The other servers, the ones on data site 2, they still know their job. Remember, you need a vCenter to build a cluster. But once you build an HA cluster, the vCenter could go down. And those ESX servers still know what to do. They're still running FDM, Full Domain Manager. They know their job. Their job is, hey, let's go restart all the VMs, and that includes the vCenter server. And here is your answer. Notice, vSphere HA recovery is independent of the vCenter server. Now, we're going to take a little break, and then we're going to start with 2-node clusters. Enjoy the break. I'll see you in a few minutes. Thank you.